Alrighty. Let's go ahead and draw some ions, guys. Um, so we're going to draw Bohr models of some ions. And, well, there's a few more vocab words that we're going to have to learn here. So don't hate me. But here we go. Cations are a positive ion, and it means they've lost some valence electrons, okay? One or more valence electron. And the anions are negative, and it means that they've gained electrons to fill their valence energy level. Okay, so before we talk about this vocab here, let's just keep this in mind here. If we lost negative electrons, we're going to end up with more protons. And that's why if you've lost some valence electrons, you end up with a positive cation. Meow. Cation. Meow. Always remember that cations are positive because cats are awesome. And, well, at least I think so. And anions are negative. They've gained electrons. Electrons are negatively charged. So if you gained some negatively charged electrons, your entire atom would end up negatively charged and become an anion. And I remember anion because of this first part of the word here. Anion is the same part of the word as antagonist, like in a story or a novel. The antagonist is the negative force or the bad guy, right? And anions are negative. Okay, here let's check out this these vocab words here: valence electrons and valence energy level. Okay, the valence electrons down here are electrons in the outermost or the highest energy level. Okay, and then the valence energy level is the outermost energy level. So the valence electrons reside in the valence energy level. Okay, let's start off by looking at a chlorine ion, okay, or it's going to be a chlorine anion. And so here we are. Okay, chlorine is element 17. I drew the isotope symbol down here. I chose the mass of 35, and I added this little charge there, -1. Okay, and then the isotope name is chlorine 35 anion. Okay, now we have 17 protons in chlorine, whether it's an atom or an ion. Okay, to make it an anion, a negative ion, we need more than 17 electrons. Okay, we've ended up with 18 electrons. That's what this open circle is there. I used an open dot to represent my extra electron that I gained. Okay, but let's think about this for a second before we go on. Okay, anions, they gain electrons to fill their valence energy level. Okay, chlorine here is in its valence energy level is the third energy level, corresponding with the third period. There's only one more space in the valence energy level in that third period. Okay, the valence energy level is this third energy level, and we've added just one more electron to it to create this negative chlorine ion. Okay, let's try this. Let's try this with another element. How about we'll do nitrogen? Okay, nitrogen is a great one to do. It's a super common element here on Earth. Okay, let's start off with. Let's get this stuff out of the way. Start off with an isotope symbol here, and so I need my atomic symbol. I need my atomic number. And I need a whole number mass. 14.01 is the average atomic mass. I'm just going to round to 14. Okay, so this is nitrogen. 14. Okay, I'm drawing a nitrogen anion, a negative ion. Okay, negative. Put that little negative sign there to remind myself. Okay, so now the question is, how many electrons am I going to gain here? Well, let's start off with a neutral nitrogen atom. Put my atomic symbol there, and then my protons and my neutrons. Ooh, my neutrons, I need to take my mass, 14, subtract my protons, that equals 7 neutrons. Okay. Nitrogen is in the second period, the second row of the periodic table. So that means I'm going to need 2 energy levels, an energy level for row 1 and an energy level for row 2. 1, 2. Okay. Now let's fill in some electrons here. Remember, we're just going to start with the neutral nitrogen atom here. Okay, 2 electrons in the first energy level. 1, 2. And now I need 1, 2, 3, 4, 5 in the second energy level. And I think it's useful to go and draw your electrons in this fashion, guys, starting at the top, one at a time. 1, 2, 3, 4, 5. Okay. Darken those in nicely. Okay. Notice how I went top, right, bottom, left to draw those electrons in there. Okay. Now, let's go ahead and remind ourselves what an anion is. Anions gain electrons to fill the valence energy level. Okay. Currently, I have 5 valence electrons. 1, 2, 3, 4, 5 electrons in my outermost or my valence energy level. I need to fill up that energy level in order to have a nitrogen anion. Okay? So, how many more electrons can fit in that outermost energy level? How many more electrons can fit in that outermost or that valence energy level? Well, here we are at nitrogen, and there's 1, 2, 3 more spaces left in the second energy level, in the second period. Okay? There's 1, 2, 3 spaces. So I'm going to just go ahead and fill those in. 1, 2, 3. Bam. Okay? Now that means I now have a negatively charged nitrogen. So I need to add up how many electrons I added, just 1, 2, and 3, and that becomes my negative charge. And I'm going to add that to my isotope symbol. There's my charge, 3 minus. Okay, and I'm going to say nitrogen 14 anion. Bam. Not too bad. Let's try another one. How about magnesium? Element number 12. Okay, get another piece of paper here. So let's draw a magnesium cation. Okay, and cations are positive. Put a little plus sign to remind myself. Okay, let's start off with the isotope symbol, Mg. Magnesium is element 12, and it has a mass of, or an average atomic mass of 24.31. So I'm just going to round to a whole number that I think is nice, and I'll round up to 25. I could round down to 24, could maybe even justify 23, could maybe even go up to 26. But 24 or 25 are probably the most reasonable. Okay. Again, there's not a specific question that I'm answering other than just draw a magnesium cation. So whatever whole number you get to using your average atomic mass from your periodic table, as long as it's nearby, then you're good to go. Okay. So this is magnesium 25. Okay, we're going to make this into a cation, which is a positively charged ion. Okay. Cations lose or have lost their valence electrons. Okay, so let's start off with just drawing a neutral magnesium atom, and then we'll transform it into a cation by losing the valence electrons. Okay, magnesium. Let's start off with the nucleus. 12 protons. And now we need our neutrons. Okay, let's figure that out. Got my calculator. 25 minus 12 equals 13 neutrons. Hey, and remember, this is a Bohr model. It's like a cartoon atom. This isn't really what atoms look like, right? Obviously, there's not a bunch of just letters in the middle of an atom. Okay, there's actual particles in the middle of an atom. This is just a model. Okay. Magnesium is right here. It's in period number 3. 1, 2, 3. Which means I have 3 energy levels. 1, 2, 3 energy levels. Okay, let's go ahead and fill those up by reading left to right, top to bottom on our periodic table. So starting at the top, 1, 2 electrons in the first energy level. There's 8 in the second energy level. There's 1, 2, 3, 4, 5, 6, 7, 8 spaces in the second energy level. Pair them up. Start at the top, go to the right, put down at the bottom, to the left. Pair them up. 8, 2, 4, 6, 8. Awesome. Okay. Now we're down to the third energy level, the third row, the third period, I should say, of the periodic table. And that corresponds with the third energy level of our magnesium atom. It also turns out to be our valence energy level. Okay, so let's add our valence electrons, our outermost electrons. There's 1, 2 spaces in that valence energy level, the third energy level. So let's go ahead and put those there. There's 1 electron, 2 valence electrons right there. Okay. Now, remember, we have a cation. It's positive. Meow. We're going to lose our valence electrons. So even though I just drew those things, we need to transform this into a cation. So I'm just going to put some X's through these. 1, 2. Okay, that's all of my valence electrons that I had. So I now have more protons than electrons, meaning that I now have a positive or a positive cation. Sorry about that. So I crossed off 2 electrons. That's going to give me a positive 2 charge. And I'm going to change my isotope name to magnesium 25 cation. Okay, let's make sure we get this real quick. We now have 12 protons. Okay, and how many electrons do I have left over? I have 1, 2 in my first energy level, 3, 4, 5, 6, 7, 8, 9, 10. All together there, 10 electrons now. Hey, if I subtract these things, that means I have a difference of 2, right? So I now have 2 more protons, and protons are positive. Guys, this is always confusing. Even though I lost electrons, I now have a positive charge. Okay, I lost these electrons. I now have 2 more protons. There we have a positive charge. So now I have a positive cation. All right, hopefully that was helpful.